Okay, hello everybody. Welcome to the NASA Earthdata webinar, Accessing Daymet Data Through Web-Based Tools and Services. This is your host, Jennifer Brennan. While everybody is logging in, we do have two polls at the bottom of the page. You can see those in the left and middle portion of your screen that we'd like for you to take a moment to answer. If you could, that would be great. I've got 2 p.m. Eastern Daylight Savings Time, so let's go ahead and get started. As I mentioned, this is your host, Jennifer Brennan. I'm also the NASA Earth Observing System Data and Information System, or EOSDIS, User Support and Communications Lead at NASA Goddard Space Flight Center. So what I'd like to do first is go over a few housekeeping items related to the webinar. Due to the large number of participants and also to ensure the best audio experience for all of you, the conference has been placed in silent mode. However, if you have any issues or any questions, what I'd like for you to do is enter them into the Q&A pod. You can see that in the lower right-hand corner of your screen, okay? That works like a chat. And then second, the webinar will be recorded and posted to our Earthdata Adobe Connect catalog, as well as to our NASA Earthdata YouTube channel. It will take me a couple of days to get that posted, and what I'll do is I will provide the URL to you at the end of the presentation. Additionally, all presentation files will be available for download at the end of the webinar. The webinar itself is 1 hour long. 45 minutes are allocated to the presentation and live demonstration, and then another 15 minutes for the question and answer period. After our speakers have finished their presentations, what we'll do next is we will move to a final set of polling questions, and then our question and answer period will follow directly after the final polling questions, okay? As I mentioned earlier, you will have an opportunity to ask your questions throughout all portions of the webinar, except during some of the live demonstrations by using the Q&A pod. But not to worry, because any questions that you've asked at any stage during the webinar, they will be captured. That particular pod is persistent. And what we will do is we will take all questions using the Q&A pod at the end. And again, due to the large number of participants, we will not take questions using the raising hand function. That has been disabled. And then just one final note, depending upon the volume of questions that are received, we will extend the Q&A period an additional 15 minutes to 3:15 p.m. for those of you who wish to stay on the line. So let's move next to the agenda. Okay. The first 10 minutes or so will provide you with an overview for the NASA Oak Ridge DAAC, the Daymet project, and a brief tour of the Daymet website. During the next 30 minutes that follow, we will switch speakers and we will move to our live demonstrations, where you will be provided demonstrations on how to discover, access, and visualize Daymet data using a variety of web-based services and tools. It is my pleasure to introduce our first speaker today, Michelle Thornton, who is the technical lead for the Daymet project at the Oak Ridge DAAC. Michelle?
Thank you, Jennifer. I'm Michelle Thornton, and I'd like to thank everybody for attending this webinar to learn more about Daymet and accessing data through the web-based tools and services that have been developed. I started working with Daymet about 7 years ago by providing spatial input files for our current processing, and now I lead most of the Daymet day-to-day activities. One important outcome that has come from my involvement with Daymet is that I've been able to coordinate the efforts of transforming the raw data outputs into the final data products that are available to the public from the ORNL DAAC's websites. I feel this has been successful because of the expertise within the ORNL DAAC, including my colleagues who will be presenting. We're able to make these data available in standardized file formats and through some great tools and services that we will share with you today. For those not familiar with Daymet, I'm going to briefly introduce the Daymet data set and then share with you the ORNL DAAC and Daymet websites where you can obtain the data. For many, Daymet refers to both the software routines and the data outputs that generate daily gridded weather data. We'll focus today on the data products and access to those products. There are 7 Daymet variables that are available as daily gridded surfaces. Listed here are the variables with the abbreviations that we use and that you'll see throughout today's webinar. So you see here the 7 variables and the abbreviations. Tmax is for maximum temperature, Tmin, minimum temperature, SRAD is shortwave radiation, VP, vapor pressure, SWE is snow water equivalent, PRCP is the abbreviation for precipitation, and DayL is day length. The Daymet model inputs include a digital elevation model and daily observations of minimum and maximum temperature and precipitation from ground-based meteorological stations. Each of the points on the map on the left represents a ground-based station. The outputs are continuous surfaces for each of the 7 Daymet variables. The image on the right is showing one of the temperature variables. Another thing to note in these images is the system of squares or tiles that overlay the images. The Daymet methodology divides the inputs into these tiles, which are 2 degree by 2 degree, and processes each tile separately. You'll see reference to tiles in today's presentation. The Daymet dataset characteristics are listed here. The spatial resolution, or the pixel resolution, is 1 kilometer. It has a daily temporal resolution. It's available by year, 1980 through 2013 is presently available. And the file formats are NetCDF. For me, one of the most exciting aspects of the current Daymet release is that it's the first time that the daily gridded data is publicly available. You can download data either as individual tiles, as shown on the left, or as a mosaic for each variable of those tiles, the image on the right. Typically, the size of a region of interest decides if you would want to download tiles or mosaics. Some things to note about the tiles data, again shown here on the left, is that each 2 degree by 2 degree tile is processed individually, but adjacent tiles edge match seamlessly. This is 1 day of data. It's January 1st for 2007, and the variable is maximum temperature. You can see the 2 tiles, the matching at the edges is seamless. The data structure is that the files are arranged by a tile ID and year. You'll see this organization in the THREDDS Data Server for tiles. And for each tile, there are 7 separate files for each Daymet variable. Here I'm showing tmax.nc, but there's also tmin.nc, prcp, precip.nc, vp.nc, and so on for each of the variables. And finally, the file format is a classic NetCDF version. For the mosaic data, like the image on the right, this is for users who need large spatial extents. Having access to the mosaic files saves a lot of time in processing the individual files, the individual tiles. Each Daymet variable is a separate file, which is arranged by year. And the file format in this case is a NetCDF, but it's version 4, which allows for internal compression, which makes the file sizes much more manageable. With this slide, I want to talk about data access options. This graphic represents a mosaic data set for 1 year and 1 variable. Let's say it's Tmax, or maximum temperature, for 2007. Packed into one file are all 365 days. your day 1, your day 2, all the way down to your day 365. Each Daymet variable is arranged this way. This can quickly become a lot of data to download, and a lot of data to process. And this is why we've developed the specific tools and services to access this data. If you're interested in only one specific site location, in other words, if you want daily data, but only for one pixel, there's the single pixel extraction tool and web services that Ranjit is going to demonstrate. With this tool and services, you can download multiple years, multiple variables, and even multiple site locations. We've had users download thousands of single site locations with this tool set. If you have a larger area of interest and want gridded daily data for that area, Yaxing will be demonstrating some of the specialized features of the THREDDS Data Server that allows subsets of the NetCDF files. Users have used gridded data in wildlife distribution models or plant growth models as an example. And of course, if you want and need the whole spatial extent, that's also available through both THREDDS and an FTP site. Now I want to talk about the ORNL DAAC briefly. The ORNL DAAC is managed by NASA in their Earth Science Data and Information System project, also known as EOSDIS. Specifically, data that is related to Earth's biogeochemical dynamics are archived within the ORNL DAAC, and Daymet is just one of those data sets. One way to access the Daymet data set is through the About Data link. Daymet is archived under the regional and global data products. If you click the Daymet link, you will go to what's called the Daymet project page. Here you'll find a lot of background information about the Daymet data set. If you click here on the Daymet project website, you'll go right to the website that's maintained by the ORNL DAAC that's specific to Daymet. So the URL for this website is daymet.ornl.gov, and you can go directly here. And many people want easy access to the data, so we have on the left this direct access site where you can access the data directly. Let me point out that there's an FTP site where you can directly download the mosaic data. Yaxing will go over the THREDDS server, and Ranjit is going to talk about the single pixel extraction tool. You can also download individual tiles through the Daymet tile selection tool. If you look across the top banner tabs, there's Access, which provides more information on each of the data access types. Description, now this is an overview of the Daymet process and data products. Documentation, here you'll find user guides for the data. If you have questions about file formats or units, this is a good place to start. The Literature tab, here you'll find links to primary Daymet model description publications as well as related publications that have used Daymet data. Under Tools, there are resources for accessing and processing Daymet data that have been developed by ORNL and also by outside contributors. If you develop a tool and would like to publicly share that tool, we can do that here and provide the appropriate credit. Ranjit is going to talk further about web services. And the last tab, Contact Us. If you do have any questions, you can send us a message, and we are happy to help you out. Finally, I'd like to point out the data citation link. If you do use Daymet data in your research and produce a poster or publication, here is information on how to cite that data set. And with that brief introduction to Daymet, I'd like to turn it back over to Jennifer and my colleagues who will go over the tools and services available to access this data.
Okay, thank you, Michelle. The speaker today is Ranjit Devarakonda, who is a computer scientist at the NASA Oak Ridge DAAC. Ranjit?
Thanks, Michelle. Thanks, Jennifer. Hello, everyone. My name is Ranjit Devarakonda. I'm a computer scientist at the Oak Ridge National Lab. I joined the lab about 8 years ago. Here at the lab, I work on many data-intensive projects, including Daymet. Today, I will be talking about single pixel data extraction tool. I will be talking about the usage and the web services that we offer for single pixel tool. Just a recap of what Michelle said about Daymet. Daymet provides gridded estimates of various weather parameters of North America, including the daily continuous surface of maximum temperature, minimum temperature, shortwave radiation, vapor pressure, snow water equivalent, precipitation, and day length. So what does single pixel tool do? Single pixel tool programmatically accesses Daymet database of daily interpolated surface weather variables based on single user-entered geographic point by latitude and longitude. Data is available between longitude -131 west and -53 west, and the latitude value between 52 north and 14.5 north. Data is available between the values that I said, and the tool extracts the daily data from the nearest 1 kilometer by 1 kilometer grid cell. The data extracted is presented to the user in a table-like format for one column of each variable and one row of each day. We have also prepared some scripts to programmatically download multiple coordinates. I will be showing that in a demo in a short while. So the current data is available between 1980 and 2013. So let's dive into the demo. First, I'm going to show the single pixel tool webpage, and then I'll be showing the web services. So from the Daymet webpage, there are links pointing to the single pixel tool extraction right on the home page under the tools section. So this is how the single pixel webpage looks like. You can see the map with gridded all over North America, showing that this is where all the data is available for Daymet. So the first step is to populate the latitude and the longitude. I can do so by entering it manually or by moving the marker on the map. At the bottom, I have all the variables listed, all 7 Daymet variables, and all years listed on the right-hand side. By default, you may notice that all variables and all years are selected. I can pick a specific variable by clicking on it, and I can pick more by clicking on and holding on the command key if I'm using a Mac, or a control key if I'm using a Windows. So here for the demo, I'm going to pick the Tmax, temperature max, and the Tmin, temperature min, and pick 2 years, 1980 and 1981. So let's see how the data looks like. So I clicked on the Get Data link, and here I'm presented with a table-like format with the column 1 of year, followed by the day of the year, and the variables that I have selected, which is the Tmax and the Tmin in degrees centigrade. So there are 2 options for me here. I can either download this data by clicking on the Download Data link. So it gives me a CSV file, comma-separated variable file format. The file name being the tile ID, followed by the day I'm downloading the data. Or I can click on the Visualize Data link, which presents me with the 2-dimensional time series data plot for the variables that I have selected. So I have temperature max and the temperature min right below it. So I can zoom into a specific time period by selecting the time slider. And by hovering over the graph, I can see the values changing on the top for the temperature max. So now let's look at the web services that we have for Daymet. Again, the web services documentation page is linked from the main menu of the Daymet web page. So basically, there are three kinds of web services that we offer. The first one is the wget and curl. Second is the browser view, and the third are the scripts. Before we get into any of these, let's understand the REST-based URL that the Daymet has. So REST service could be split into three parts. First part is the base URL, followed by the service type, followed by the arguments that we want to pass to the REST URL. Depending on how you want to view the data, you can select the service type. For example, if I say save data, meaning I would be saving the data onto my desktop. Or I could do a query as a service type, which would let me view the data in a browser. You may notice that latitude and the longitude are the required elements in addition to the service type. And the other arguments, which are the measured parameter, which is a comma-separated variable list, and the years, comma-separated variable or years, are two optional parameters, meaning I can completely omit them if I want to see all variables and all years. Okay, now let's look at the first option, which is wget and curl. So basically, these two are like simple to use command line options. Wget returns an ASCII text file in a CSV format, and the curl returns the data into the terminal, but you can output the data into any of your scripts. So let's look at the wget option. Now I'm going to switch over to my terminal. So here I have a wget command with the output file location, with the output file name as output CSV, and I have the base URL. So if you notice, I have a save data as a service type, which would let the data save on my desktop. And I have a latitude specified, longitude specified, and the measured parameters would be Tmax and Tmin with years as 1980 and 81. So let's see what happens if I execute this command. So it says that the CSV file has been downloaded onto my system. If I open it, you may notice the same table-like structure with the years in the column 1, followed by day and the variables. Also has how to cite the data, the years that I have listed, the elevation, the tile ID, etc. So this is one option. Going to the second option, which is the browser view, I'm going to do the same thing here, except I'm going to use this on a browser. I'm going to paste the URL in the browser, and now I can see the data presented on the browser view. So here I also have options to download it and visualize it like I've shown before. The third option is via scripts. This is particularly useful for the people who wants to download for multiple locations for single pixel extraction. So there are instructions right below it how to use it, but I'm going to show it as a demo. So the first step would be to download the script. I can do so by clicking on this link. For the interest of time, I have already downloaded it on my system. So once I download the script, unzip it, I have 5 files inside it. The first one is the latlon.txt, which is the input file for the script, and followed by there is a executable JavaScript which would take the input file as a parameter and show the results. I also have a README file with instructions, and I have a log file which would capture any errors that occur during this process. So the executable jar is already inside the shell script for easy access. So now I'm going to run a command using the executable passing the latlon. Okay, before that, let me show the input file. So in the input file, I have the output file name, how it has to be specified. I have the location, latitude and longitude. I could have as many as possible for downloading multiple site locations data. So that's how the input file looks like. So now if I run this, you can see that it's processing. The base URL is saved data again with the latitude and longitude, and I am not passing any years or the variables list. So I would be downloading all years and all variables for this location. So while this is processing, let's look at the files. So I have two files generated with the output file name. I'm going to use Microsoft Excel to open it. So you can see all variables listed, all 7, and goes down to from 1980 all the way till 2013. So that was a brief demonstration about the web services and the single pixel tool. Now I'll transfer it back to Jennifer and then to Yashing Wee, who would be showing us the THREDDS catalog service.
Okay, thank you, Ranjit. Finally, our speaker today is Yashing Wee, who is a geospatial information scientist at the ORNL DAAC. Yashing?
Thank you, Jennifer. Thank you, Michelle and Ranjit. This is Yashing Wei. I'm a geospatial information scientist at the ORNL DAAC. I have been working in the ORNL DAAC for more than 7 years and been leading the web-based geospatial data visualization and distribution activities, including for Daymet. Next, I'm going to introduce accessing Daymet data through THREDDS Data Server. So you have learned that you can get Daymet data through FTP download or the single pixel extraction tool. So why do we need this THREDDS Data Server? So it's here to serve your needs better. For example, you may want to see maps. Before downloading data, you may need the Daymet data for a specific spatial area instead of individual pixels or the whole North America. And THREDDS Data Server can help you with those. And what is THREDDS Data Server? It's a web server that provides online browsing, visualization, and access for scientific datasets using OPENDAP, OGC Web Coverage Service, Web Map Service, NetCDF Subset Service, and other data access protocols. Please do not get confused with those acronyms because these are just the different ways for you to visualize and access data. And many of them are community standards. And THREDDS Data Server has many good features. And it's very easy to use. Its web user interface is similar to an online file directory. It provides dynamic and interactive maps for you to visualize data. And you can do variable, temporal, spatial subset. And since it supports many community standards and many other software and tools can use it directly, including ArcGIS, MATLAB, R, etc. And next, I'm going to demonstrate how to find, visualize, and access Daymet data of your interest from THREDDS Data Server. And in this demonstration, I'm going to focus on the Daymet mosaic data instead of the tiles. So following the link provided in the previous slide, or you can follow the link provided on the Daymet project website, you will reach the THREDDS Data Server page for Daymet. And this is the home page for THREDDS Data Server for the Daymet product. And you can see it looks exactly like a directory structure. And each subdirectory here is for 1 year. And it starts from 1980 all the way to 2013. That's the available time range for the current Daymet product. And click into one directory. Let's say click into year 2000, and you will see 7 Daymet date files listed here, and also the size of each file. Say you are interested in daily maximum temperature, you can click on the name of that file, and you will go to another web page that contains the metadata about that particular file, the daily maximum temperature. And this web page contains the metadata like the URL link to the user guide and different date access links, and also some other properties like the time range for this particular data file, and also the coordinate reference system definition in the project format, and the bounding box in its native coordinate reference system, and also the citation information. And this coordinate reference system definition is very important if you use a tool that cannot understand NetCDF coordinates very well. So you have to define it manually in your tool, and you will need this Project 4 definition for the coordinate reference system. And at the bottom of this page, you have a few options to visualize this year 2000 daily maximum temperature, including Godiva 2 and the NetCDF Java Tools UI. But in this demonstration, I'm going to pick the Godiva 2 option because it's a browser-based, so you don't have to install anything to use it. So let's click it, and by default, you will be able to see a viewer in the middle of this page with blue marble base map, and then the Tmax_2000.nc4 listed on the left panel. And you can click on the plus icon here, and you will see 3 plotable variables, including latitude, longitude, and daily maximum temperature. So latitude and longitude variables are auxiliary coordinates variables for the daily maximum temperature variable. And you can click on them. You can click on the name, for example, the latitude, and see how this latitude variable looks like on the viewer in the middle part of this page. And this is latitude, and then click longitude. And you can see how the latitude and longitude values change from south to north and from west to east. But of course, you are more interested in the date itself. So let's click on the daily maximum temperature variable. And this time, the viewer will be updated automatically with daily maximum temperature map loaded. And remember, this is interactive map viewer. So you can zoom in and pan this map to see some details if you want to check something. And also the legend of this map is just right beside the viewer. And you may want to ask what day this map represents. And the top right corner of this page shows a calendar. And it says this is December 30th and in year 2000. And this is the last available date for Daymet data in this particular year. Remember, Daymet always has 365 days for each year, no matter it's a leap year or not. And for leap years, the last day in that calendar year, December 31st, will be dropped. So this is the case for year 2000, and that's why the last available date for year 2000 is December 30th. And you can pick a different date on the calendar, and the viewer will update the map automatically. So let's navigate to some previous dates, and you can see how the map changes automatically, so you can have a sense of how the map looks like, how the data looks like, before you decide to download the data. Now let's navigate the calendar to, say, July 2000. You can navigate to July and pick, say, July 1st. You want to take a look at how the data looks like on that particular day. Let's click on July 1st. And now you see this map looks very red because the temperature, of course, in July is much higher than December. And this map doesn't look very nice. So you want to adjust the legend value range to make the map look more red and blue balanced. So let's change. Notice this little box here. That's the upper limit of the legend for the map. So let's change the upper limit to, say, 50 Celsius degree. And the map will be updated. And it still looks red. Let's change the lower limit to 0. And click outside of the box, and the map will be updated automatically. And right now you see a more balanced map. So this is just for visualization. And there are some other nice features provided by this viewer. For example, first, you can left click on anywhere on this map, and you will see a little pop-up window. And this window shows the coordinates, the latitude and longitude values of the point that you just clicked. And also the value here, the value on that point. This is 27.5. This means the daily maximum temperature for this particular location on July 1st, 2000 is 27.5 Celsius degree. So this is the first nice feature, and there's another nice feature. To use that feature, first you click this little icon on the top right corner of this viewer, and then you draw a line on this map by first clicking, and you choose a starting point, and then click again, choose some other points in the middle, and then you can draw anywhere. Basically, you can finish the drawing by double click. And now you see another window pop out. This is actually the profiling tool. It shows the transect for the daily maximum temperature along the line that you just drew. So this is some other nice features provided by this viewer to allow you to investigate the data more closely. And now let's assume that you are happy with this 2000 daily maximum temperature data and want to get a subset of it in somewhere like Tennessee area for July 1st and July 2nd in year 2000. Then let's go back to the metadata page for this particular file and go to this access section on this page, and you see a few options for you to download data. But in this demonstration, I'm going to pick the NetCDF Subset Service because this is one of the easiest options to use to subset and download data in NetCDF format. So let's click on the NetCDF Subset link here, and it will take you to another page. And on this page, you see on the top right corner of this page, you see a nice little map here. And this map shows the bounding box, the overall bounding box. That's the available spatial extent for this particular file. So below that viewer, you have the option to specify what's the spatial extent you want to subset. So you see this, you need to provide 4 values. The west coordinate, the east coordinate, south, and north. And we just mentioned that we wanted to download subset data in Tennessee area. We need to find out what's the bounding box for Tennessee. And I found it. I know it's starting somewhere from a -90. That's the west longitude. and then ends at -80. And the latitude ranges from some value like 34 to 37. And we just decided that we wanted July 1st and July 2nd. So we want 2 days. That means we need to change the starting date and end date. That changes the starting date to 2000 July 1st and end date to July 2nd. And also, of course, we need to check what variables we want to subset on the left side of this page. We want to download at least the Tmax. You may choose to include the latitude and longitude variables also, but those are just the auxiliary variables. So we just check Tmax here. And then at the bottom of this page, you see you have 2 options to download the data. NetCDF, this is the version 3 classic format, or NetCDF 4 format. I always prefer NetCDF 4 because NetCDF 4 provides some nice features like internal compression, and also it's much faster to use compared with regular NetCDF version 3. Okay, after specifying all those criteria, let's click Submit. After a few seconds, you will see this window pop up, allowing to save the file or open it with some tool. And for this demonstration, I'll open it with Panoply. And this is a nice NetCDF file viewer, and it provides you some nice features. First, you will see the detailed header information on the right part of this tool. And also, on the left part, it lists all the variables included in this NetCDF file. This time, this is the Tmax. And you can visualize it by double-clicking on the variable name. And you see this little subset map. It's somewhere over Tennessee. And you can change the map a little bit to see the details. So let's change the projection, and then you can navigate somewhere to this little map. Okay, you can zoom in to see the details. And also I want to point out that at the bottom of this tool, you have 2 available time steps. The first one is July 1st, and the second one July 2nd. So you can change to see the difference between those 2 different time steps. So that's the, you can see the location of this subset and also the temporal availability of this subset date file. So this is a brief demo of the THREDDS Data Server, and I want to point you to this particular website. This is threads.daac.ornl.gov. And THREDDS has many other features. You can Google some documents about THREDDS. You will find a lot of stuff. But the ORNL DAAC also provides some useful tutorials on its website. It lets you know how to use the THREDDS Data Server in some tools like MATLAB, Python, and ArcGIS. So you may want to check those. And also, if you have any questions, we'd like to answer those, or you can contact us directly after this webinar. So that's the brief demonstration. Thank you.
Okay, thank you, Yashin. So we will now move to the final set of polling questions, and we'll give these questions just a couple of minutes or so, and then after that, what we'll do is we'll move on to the Q&A portion of the webinar. So please be sure to stay in the room and or stay on the line if you'd like to participate. All right, let's give these just a couple minutes here. Thank you. So just as you're taking a look at the polling questions, I see that some people have entered some questions for Daymet Data Utility. Try to remember those, or we can also take a look at this all after we address any questions that have been entered in the Q&A pod. So I guess what I'd suggest is for those participants, go ahead and also enter them possibly as a question once we move along. We'll give this just another minute or so, okay? Thank you. Okay, everybody, we're going to go ahead and move along to the question and answer period. I've noted some of the comments that were made for the Daymet Data Utility, and hopefully I can capture those after we answer questions here. Okay, so let me take a look through and see what we've got. Okay, so why don't I ask some of the questions while you're considering questions for the Q&A pod. One of the comments on how to make the Daymet data more useful, and I will list off a few of these for our speakers who are in the room there at Oak Ridge. One of the questions had to do with, can you include wind speed for the Daymet?
Hi everybody. We have in the room Peter Thornton, who's the Daymet algorithm the algorithm guru. So we'll let him address that.
Yeah, that's a very challenging variable to do with the methods that we're currently using, and the reason is that we have very few observations of the wind speed and wind direction from which to do the interpolation. There are great models out there that will do an atmospheric dynamics-based calculation of wind speed and wind direction, and we could conceivably connect with data streams from models like that, but there aren't good, just simple interpolation methods that can take point-based estimates of those parameters and do a good interpolation to a gridded surface. You really need the atmospheric dynamics engaged, which is a much more complex problem than we're tackling here.
Okay, and then a couple of the other comments is there global level data available?
We are currently working on expanding our North American extent, and part of the challenge with extending further north into North America, into Canada and Alaska, and also going to a more global extent, are having access to daily data and also having access to a density of stations that allow for a good interpolation. So we're working on improved methodology, improved algorithms to address that, and we hope to, within the year, have that extension into areas further north, and from that we are looking globally. but we're going to try to tackle North America, further north first.
Okay, so thank you, Michelle. And that actually addresses a couple of the other comments that I noticed, which were whether or not you would extend the coverage across North America, and then one of the participants asked about coverage over Asia. So I think that you have addressed those two comments that were made for that polling question. Another comment that was made was whether or not you have averaged monthly raster data available.
We do have average monthly raster data available, and we are working on getting that onto the ORNL DAAC Daymet website so that people can access that as they need it. I have distributed that data through another FTP site as people ask for it. So feel free to use that Contact Us page if you're interested in either the annual or monthly climatologies, and I can put those data on an FTP site and let you know where they're at. And they are in a GeoTIFF file format.
Okay, thank you, Michelle. So there are a couple of questions that are related to the webinar, but I will address really quickly. One was, what's the name of our YouTube channel? So the YouTube channel, if you look for NASA Earthdata, NASA, and then capital E, EARTH data, and I think I typed that into the pod. The webinars, we have our archived webinars there currently. They're also archived at the tinyurl.com Earthdata webinar. So this webinar probably won't be posted till Monday, possibly tomorrow. Okay, and then the other question was whether or not the presentations are available for download. Yes, I have posted each of the sets of slides down below in the file sharing pod, and just to let you know, this is a persistent feature, so if you go back and listen to this webinar later, you will still be able to download those files. And I will keep the room open for a few minutes when we're finished with the questions for those of you who would like to download the files, okay? Let's see, any other questions? I don't see too many questions here. Don't be shy. Questions, anybody? Go ahead and type them into the Q&A pod if you do. So I don't see okay, here we go. Right, perfect. Okay, our next question, how does Daymet compare to other regridded station products?
You want to take that one, Peter?
Are we
Nope,
unmuted? Okay.
We're good.
Yeah, there have been some previous comparisons to, in particular, to the Prism product. There's been some, so those have been regional, the ones that I'm aware of, comparing in parts of the Rocky Mountain West. And what that's shown is, as well as comparison in that case to the ANU spline product, and they generally see that in some places one product is better, and in other places another product is better, and it varies by variable and by time and space. And I don't believe there's been a conclusive statement about one of those products being overall better in terms of quality than another when they're compared on the basis of the available data set. So the one thing that is different about the current Daymet data product is that it's calculated on a daily basis, and it's on a 1 kilometer grid spacing, which is a finer resolution than available for other products at the moment.
Okay, thank you, Peter. So the next question is, how is SWE calculated?
Snow water equivalent, that's based on a very, very simple snow pack accumulation and melt model that uses the temperature and precipitation data as its only inputs. So for example, when I say simple, I mean that many more sophisticated snowpack accumulation and melt models are out there, which would include radiation and humidity and the influence of rain on snow events. And this current implementation doesn't do any of that. It's really included as just a simple first order check on kind of snow balance as a data quality check. But yeah, there are many better approaches out there. In fact, better approaches that could be implemented with the data inputs that we have from temperature, precip, radiation, and humidity.
Okay, thank you, Peter. The next question is, could you post close to real-time data?
Most of our processing comes from two main sources for the U.S. and Canada, and that's the GHCND and SNOTEL inputs. And when we started this process, actually about 7 years ago, those actually GHCND didn't have the co-op data under that umbrella, and snow time wasn't real time. So when we started this process, the live data stream of input data didn't really exist. That has changed considerably. But still, our processing doesn't really allow for that real-time data processing. In fact, I tend to wait 2 months before I download data from both SNOTEL and GHCND to make sure the data is as quality checked and non-provisional as it will be, and still allow a timely processing for that year. So our current plan is to do yearly updates and not tackle the real-time processing.
Okay, thanks, Michelle. The next question is related to the temporal range for the data product, and it is, I may have missed this, but why did you start in 1980?
So the original processing was based on the availability of SNOTEL data from that network. The intention was to have the best quality data set that we could across the whole U.S. And in order to get any kind of reasonable quality in the Mountain West, we had to have the SNOTEL data available for the extrapolation part of the algorithm to be able to get up to high elevations with reasonable data quality. And the SNOTEL telemetry network data set really only gets good coverage starting in about 1980. We have some research plans on the table for how to use the relationships that are diagnosed since 1980 to try to apply some relationships, some statistical relationships to go back in time. And some other systems have already been implemented that look at that. I can't speak to the quality of those outputs. I haven't. I don't know how capable those methods are at this point.
Okay, thanks, Peter. The next question for everyone is, does Daymet processing include any screening for faulty weather station data?
Only insofar as GHCND and SNOTEL do their own internal quality control. We don't do much more beyond that except for looking for values that are out of range, out of a reasonable high-low range.
There's actually one other level of checking that's done, which is based on cross-validation error statistics, which is possible for the temperature data, but not really possible for the precipitation. So if a cross-validation error check is way out of bounds for a particular station observation, we scrutinize that and in many cases will throw out the observation. And by looking back to see what gets thrown out that way, we can see that that's one way to identify outliers that that wouldn't get picked up other ways.
Okay, thanks, Peter. And then the next question is, what about 2014 data?
So like I said earlier, what we're doing currently is waiting for the year to end. So we'll wait for 2014 to end, and then I'll wait an additional 2 months for GHCND and SNOTEL to have their quality checks in set, and then download data from those two sources and start processing. So we are usually 2 months behind in our processing because of that.
Okay, thank you, Michelle. Our next question is, any plans to provide sub-daily data, for instance, 3-hourly or 6-hour data?
We do have plans. There's a current development project that's funded under NASA's Terrestrial Ecology Program. That's one of the objectives of that project. Over the coming year, we'll be introducing sub-daily temperature, which is pretty straightforward, radiation, which we already make those calculations, we just haven't saved them out to the data files. Humidity is a little bit more difficult. Relative humidity is simple, but changes in absolute humidity or vapor pressure are less predictable with any kind of diurnal cycle. And then precipitation is very difficult to do from the basis of the daily observations, but we've made some headway on evaluation against the NexRad radar network data over the U.S. and are able to do some sub-daily interpolations based on that data set. So we'll probably take it in that order: temperature, radiation, and then humidity and precipitation last, just sort of taking the low-hanging fruit first.
All right, well, thanks, Peter. I'm looking through. Any other questions from anybody? Let's see, anybody? I don't think I have missed anything here. Let's see. Okay, so if there are no further questions, what I will do is we will log off from the telecon for those of you who have dialed in. However, again, I will keep this room open for another 10 minutes or so. For those of you who have additional questions, feel free to type those in or download the files. But again, remember that the presentation files will be available within the webinar once it's posted. So you will not have missed it. You'll still be able to do that. All right, let's see what we've got. Oh, and you're welcome, and thank you everybody for joining us. So I'll just give it a couple more seconds. If there aren't any more questions, we're going to go ahead and log off. And I thank you very much for joining us, and we hope to see you at our next webinar. Actually, our next webinar will be Landsat Data Discovery and Data Access on October 8th at 2 p.m. Eastern Daylight Savings Time. And, I will have that posted this week. So if you check the tinyurl.com Earthdata webinar, you'll find an announcement for it. All right, thanks everybody. I don't see any further questions, so we're going to go ahead and log off the telecon. Bye-bye now.
Bye-bye.
Bye. Bye.